Okay, some more problems from the Chapter 6 review, and this is number 6, and this is a definite integral from 1/2 to 4 of x squared plus 3x all over x, and all I have to do is just break this up. Remember when it's tough, break it up. And x goes into x squared x times, and x goes into 3x 3 times, and this is very easy to take the antiderivative. This is just going to be x squared over 2 plus 3x, and that's going to be evaluated from 1/2 to 4. And this is going to be your f of b, right over here, f of b minus f of a. Using the fundamental theorem of calculus, so here we put 4 in here. So we get 4 squared over 2 plus 3 times 4 minus, and this is going to be 1/2, 3 times, this is going to be 1/2, 1/2 squared over 2 plus 3 times 1/2. Okay, 4 squared is 16. 16 divided by 2 is 8. 3 times 4 is 12. 1/2 squared is 1/4 divided by 2. 3 times 1/2 is 3/2. 8 plus 12 is 20. Minus, and then 1/4 divided by 2 is like 1/4 times 1/2, which is 1/8 plus 3/2. This is 20 minus. Now this is 1/8. If I make these eighths, that's like 12/8. Multiply top and bottom by 4. So 1/8 plus 12/8 is 13/8. So I got 20 minus 13/8. Put it all in eighths. And 20 is the same thing as 160 over 8. Just multiply the top and the bottom by 8. Minus 13 over 8 is 147 over 8. I think that's what they had in the book. Okay, number 7. Some of these look really difficult. Sometimes they're the most easy to do. The integral from 0 to pi over 4 of e to the tan x secant squared x dx. So it looks pretty formidable, but what's the derivative of the tangent? Secant squared. So let u equal the tangent of x. So I got e to the u times secant squared dx. I'm shooting for e to the u du. And I got this perfect match over here. Look at this guy over here. There's the secant squared x dx, and there's my secant squared x dx. So there's my du. That's no problem. And then since u equals tangent, this is going to be the tangent of pi over 4. This will be the tangent of 0. The antiderivative of e to the u is just e to the u. E to the du, I should say, is e to the u. And the tangent of pi over 4 is 1, and the tangent of 0 is 0. So this is just going to be evaluated. This is my f of b minus f of a. E to the 1 minus e to the 0, which is just e minus 1. So there you go. Alrighty. And then number 8. Let's take a look at number 8. Okay, the integral from 1 to e of the square root of the natural log of r divided by r dr. Well, what's the derivative of the natural log of r? You always kind of check that, which is 1 over r, and I do have that. I've got r in the denominator, so I can fix this up. So I'll change this to the natural log of r to the 1/2, so I can think of it as a power rule. And do I have u to the n du? Yes, because the derivative of that's that. To kind of look for these things, you know, it's a lot of your ability with derivatives. If you see that you have the derivative of something, then you try to get that. U to the n du or 1 over u du, something like that. And that's what we got. This is pretty easy. So rewrite this like this. And you see it looks like u to the n du. So u is natural log of r. So that's going to be u to the 1/2. And I have 1 over r dr. But I know the du is 1 over r dr. So instead of writing 1 over r dr, I've got a perfect match. This is du. So there's my du. And then I'm going to substitute these in because u will be the natural log of r. So this is going to be e. So this will be the natural log of e. And this will be 1. This will be the natural log of 1. And what's the natural log of e? E raised to what power is e? 1. E raised to what power is 1? 0. And I'm just going to evaluate this, and I'll take the antiderivative of u to the 1/2, because I have u to the 1/2 du. U to the 1/2 du. And that's going to be, if I add 1, that's going to be 3/2 divided by 3/2 or times 2/3. 3/2, u to the 3/2 divided by 3/2, which is times 2/3. And I'm evaluating that from 1 to 0. And again, we have a situation where the 0 term is just going to drop out, so I got 2/3 1 to the 3/2 minus 2/3 0 to the 3/2. That's just going to 0 out. So we just have this, and 1 to the 3/2 is just 1, so I just have 2/3. Okay, and all done. Okay, then number 11. The other two, I think, were from section 6.3 and 6. They're both from section. Well, one was from. Yeah, they. Oh, 10 wasn't. 2x. No, 10. They're from 6.4. Partial fractions. Okay, let's take a look at number 11. Okay, so we have cosine. Now, what's the derivative of the sine? Cosine. So it looks like I got 1 over u du. I'm shooting for that. So you look for this. The derivative of the sine is the cosine. So I can think of this 1 over u du. Remember, we look for two things, first of all. 1 over u du or u to the n du. I should say probably u to the n du first, then 1 over u du. So do we have the derivative? Looks like I got the derivative here. This. So I'll kind of rewrite this so it's a little bit easier to see. 1 over u du. And I'll let u equal 2 sine of x. So I'll rewrite this as 1 over u cosine of x. Now these were just indefinite integrals, so I didn't have to evaluate. So in a lot of ways that's a lot easier. Okay? So I've got 1 over u times the cosine, but now if I take the derivative of u, which is 2 negative sine of x, I can take the derivative, and that's going to be 2 negative, and the derivative of the sine of x is the cosine of x dx. I don't want the negative, so I divide both sides by -1, and this is my match here. So this matches with this. So instead of writing cosine x dx, I can write du over -1. And then what happens, I can bring the -1 out in front. I got 1 over u du with a negative sign, negative. And the antiderivative of 1 over u du is the natural log of u plus c. And I've got the negative, all this. And then what's actually u? U is that. Okay, and then number 12. Okay, I've got an exponent. It's to the 1/3 power, but what's the derivative of 3x plus 4? Just 3, so this is very easy. I can work this out to be u to the n du because I've got this to a power. So what I did was I thought of this as to the 1/3, and I put it up on the top, so I got -1/3. And this is going to work out because I'll let u equal 3x plus 4, and I make that substitution. So this is going to be u to the -1/3 dx. Now I have to get a du there, so I'll take the derivative of u over here, and I get 3 dx. And then if I divide both sides by 3, I get dx equals du over 3. So there's my match. Dx. Let's write du over 3. And I bring the 3 out, so I've got 1/3 u to the -1/3 dx. And then I just take the antiderivative, so I got the 1/3 in front, and then I'll just raise this up by adding 1. I'll add 1, divide by that. So if I add 1, I get 2/3, and if I divide by that, that's like multiplying by 3/2, and there's a plus c, and then these 3's cancel. This other one is absorbed in c if I multiply that out. So this is what I've got. The 3's cancel. So I got 1/2 u to the 2/3 plus c, but what was u? If I go all the way back and see over here, u is 3x plus 4, so I got 3x plus 4. So I got 1/2 3x plus 4 to the 2/3 plus c. So those are those two indefinite integrals, okay? Again, go through these, think about these, try to develop some skill in these, and then I think you'll be okay. Hope those help.